Right, just done a quick play test to see where we are up to with things, and a couple of things. Let me see if I can put the stripper on. So this flipper, the EOS doesn't work because look, you can pull it down. It doesn't re-trigger, so that needs addressing. It's actually very weak, this flipper. It's probably because the power side isn't working. What else have we got? So obviously we've got the problem with the drop target. So one didn't even trigger that time. 3 did. Okay, yes, it just doesn't work right. We need to look at that. Oh, and this drop target. So let's do a pop bumper. So that works nicely. This one at the top sticks down. I'm not sure why, because if I power this off, it actually moves really freely. There's nothing jamming it. Is it actually electrically? I wonder if it's electrically holding it down, because yeah, the mechanism itself does turn the machine off, and the mechanism is nice and free, no problem. So we need to address that, because that's probably what was causing that fuse to blow. So I thought I should have a look at what is wrong with the lamp brightness instead of just moaning about it, and we've basically got 2.1 volts DC, so I'm just measuring from ground strap to the common lamp bus. I have replaced the pins on the board and the connectors, so they're all good. The problem is almost certainly going to be the bridge rectifier. It may only be working in half wave, maybe it's lost one of its segments. How do we put this onto AC? Let's see what the ripple is. Yeah, it's pretty much 3 volts AC, so I think that bridge rectifier has failed. That's fairly certain now. Okay, and it's exactly the same at the test point on the rectifier board, so we've ruled out the wiring anyway. I'm just going to make sure that the fuse holder is good and the fuse is good, it's not high resistance, but I'm fairly sure it's a bridge rectifier. Power supply back on the bench again, so we can have a look at this voltage problem, which is going to be related to BR1. This is for the insert lamps. Now you may be asking, why have I not just fixed this properly yet and just put 3 new bridge rectifiers on the front, put heat sinks on them, and that's it, job done. There are 2 major component suppliers in the UK that offer traceable parts, and I tend to only buy traceable parts where possible, because I've learned this lesson many years ago, that if you just buy random parts off eBay or Chinese suppliers, they're just not reliable. You don't know where they've come from, whether they've been handled properly, stored properly. So yeah, 2 suppliers I use. Number 1 has none of these in stock, and number 2, I had a massive problem trying to log into my account, which took several days for customer services to resolve. So that has been resolved, and I have ordered, I think I've ordered 50 bridge rectifiers, because I do use a lot of them in repairing people's pinball machines. So I've ordered them, but it's nearly Christmas, so I probably won't see those for a while due to the postage problems at the moment. So I'm going to do a temporary fix just because I want to see it working. So I'm going to take this board off and we'll take that bridge rectifier off. Right, I can show you exactly what's failed on this bridge rectifier. So we've got the negative clip on the positive lead of the bridge rectifier, and that goes to one of the AC terminals. We should see a normal diode voltage drop, and we do. And then if we switch to the other diode over here, we should again see a normal voltage drop, but we don't, we're seeing double, so that diode has failed. I actually tested all diodes and there's another one that failed as well, but you get the idea. So that has definitely failed. I mean, look how tiny that is. That's a really small bridge rectifier for fairly high currents being on 24/7 in an arcade for 30 or 40 years. So here's the quick bodge to get things working. So just soldered some fly leads on where the original bridge rectifier was, soldered on a Chinese bridge rectifier. I'm going to stick a heatsink on this to give it a fighting chance. Obviously we're not keeping this, it's not a decent quality part, so it probably won't last long anyway. So when the genuine bridge rectifiers arrive, hopefully early new year, I will get those fitted, all 3 of them on the front, and put heatsinks on. But for now, this is what we will do. Just to test it, I'll go and grab a heatsink. There we go, heatsink is on. That's the largest bridge rectifier one that I've got in stock. and that should be good enough for testing. Right, back in the game, let's fire it up. And hopefully, oh, we've got a bad socket there, that's gone out again. Hopefully we'll see normal brightness lamps. Oh, there we go, that's much better. Still got a few lamp problems. I've got a different solution that I'm going to do. So as part of the full restoration, I'm going to replace this playfield entirely, and when I do that, I'm going to be replacing every single socket. So this is just getting this working for now with the crappy playfield. Yeah, if I put this into all bulb test, it's very dim again. It can't handle having all the bulbs on. Something's still not quite right with this. Right, I've got it hooked up to test point 1 and the ground strap. Let's check what voltage we're getting. Oh, okay. That's a big improvement. So we were getting, what, 2.5 volts, I think, before? Because obviously one leg of the bridge wasn't working, so we're getting basically half wave rectified. This is now full wave rectified. Oh, you can see it's dropping a bit. So now that the lamps have started flashing, it's going down to below 5 volts. Let's put it in test mode. So this is all lamps flashing. And yeah, it's dropping to 3.8. Yeah, 3.8. Okay, so we know the bridge rectifier now works fully, as it wasn't before, but we've potentially got a resistance issue. It's not able to supply full current. So we've got, obviously, the wires go from the transformer to the rectifier board. Is there any high resistance in the wires? Goes in, basically soldered directly to the back of the board. Then it goes to the fuse holder. So is the fuse holder or the fuse itself high resistance? I've already checked those on the bench and they seem to be okay, but I need to check it again. So potentially we've got an issue with the fuse or the fuse holder or the wiring. And it's pretty much go straight to the bridge rectifier after that. So there's not very many places that there can be a problem. So we need to see why we're getting this dropout. Right, just hooked up across the fuse holder there to see what voltage drop we're getting across the fuse, and it's not a huge amount, but you can see we're getting some as the lights flash. Let's try a different fuse and see if that improves it at all. And the answer is no, it's pretty much exactly the same with a different fuse. I did clean the fuse holder, but I guess we could try replacing it. We're not going to do that though until we actually get the bridge rectifiers and actually finish this board off properly. I potentially could also replace the wiring from the transformer to the rectifier board to see if that helps reduce the resistance, but we definitely have a resistance issue. So I've just soldered up some of my arcadeuk anti-flicker boards. These work on Bally and Stern classic pinball machines, and it basically allows you to put LEDs in instead of bulbs, which you can't do by default, as the lamp boards use SCR drivers which need a certain amount of current to function. So these basically add additional load through resistors, and that stops the flickering. So we can show you that in the machine. So I've changed just these yellow bonus lights to LED, just to demonstrate the problem and why you need the anti-flicker board. So you can see, let's just get zoomed in on one, you can see that they're flashing rather than lighting up. So next I'll install the anti-flicker board and you'll be able to see the difference. The first step is to remove the connectors from J2 on this side and then J1 and J3 on this side. Then we install these boards as shown. So that's the 23 pin board over there. The header pins go towards the outside, and then these two pins go towards the bottom. Then if we look on this side, again header pins go towards the outside, header pins towards the outside, and the 2-pin connectors go towards the bottom. And then the second part is we need to refit these connectors. So we just put these on, making sure to line up the pins and just gently press them on. Try to hold the board as you're doing it and push with the other hand. Do that for all 3 of those. So the final step is to attach the wire to the voltage supply for the lamps. So let me show you how that works. So we've got this one wiring harness that comes with the boards, and it has 3 connectors and then a long wire with a bare wire on the end. Now, just for ease of filming, I've just threaded this through the clips already. So what we need to do is we need to attach it to the voltage supply for the lamps. The way you find that's going to be different on all games. So there's two types of lamps on the backboards. There's the GI, so you'll see the GI is this constant rail like so with multiple bulbs on it. Now the controlled lamps, so controlled lamps will be things that say flash for game over, etc. They will be on, they'll have a common wire across one side like so, but then the individual segments, so that those two are together, this one's on its own, they'll have a wire going to each, and that's how you tell the difference between the GI, where it's all two rails because they're together, and the controlled lamps, which have individual wires. These are the grounds, this is the voltage. So we've basically hooked this wire over the voltage, and I'm just going to solder that on so that it's permanent. Now you don't have to do that if you don't have the ability to solder. You could twist it on, put a crock clip on or something, but you need to attach it to that voltage rail there. So after that's attached and you've threaded it through the harness, you basically want to follow along the harness that goes from the backboard to the boards, and we just want to cable tie. We're going to cable tie this all the way along here and then up here to plug the first connector onto here. I'm just going to do the cable tying off of video and then we'll come back. So there we go, that's the cable tying done. Now every game is going to be different, but you basically want to aim for something roughly like this. So we're following the main harness. The only reason we're doing this is just so it doesn't get caught in the door, so that it'll basically close without getting stuck. So you go follow this harness along until we come to about here, leave a little bit of slack to make it easy to plug in, and then we're just going to plug this in to these two pins, just to show you. So we just plug them onto there, and that's that. So the next job is to route this along the harness again, back up to the other side. Right, so I'll show you what we did. So just cable tie it along the main harness so that it's following along to the other side, and you just, all it needs to be is just neaten it up so it's not going to get caught or stuck in the door or anything. And then once you get here, you've got these two connectors on a short bit of lead, so we'll plug this first one in at the bottom here, and then the second one just goes like this. And there you go, and then we'll just do some final tidying up, tie that to the loom, and make it neat, and then we can test it out. And if you did everything correctly, we power the game back up, and remember we've only changed these yellow ones, these are the only ones we're looking at, and now you can see that they are smoothly chasing rather than flickering as they move, and you should be able to see a huge difference even on the camera. There you go, that's that job done. So I've just been putting a few more LEDs in to try them out. So this is one where I've put a blue LED in, and it's this colour here. Now over time this is supposed to be blue, but it's turned into like a light purple / pink. So hopefully by putting blue LEDs into all those, we'll restore them back to normal blue colour. Same with those on the top, they're supposed to be blue, but they're like a purpley pink. So I will carry on putting some more in, and not sure about these ones, they've gone like a grey. I don't know whether to go with blue or pink in those. They kind of look like they maybe should be pink. Let me see if I can find some pictures of a new playfield. I've actually got a new playfield now, but it's not here in this room. Right, so these ones that have gone grey are supposed to be purple on this game, and the ones that have gone purple are supposed to be blue. So that's a blue and that's a purple. I'll put pink in for now in the purple ones until I find some purple LEDs. Okay, all LEDs installed in the insert lighting, all general illumination has been left as regular bulbs, as that's how I prefer my machines. I don't like crazy coloured GI, but everyone likes what they like. So they're all working. Oh, there's two I can't do, so that one there, and there's the other one there. That's the two arrows. Because of the way the bulb holders are, I need to get the LEDs that are on like a flex lead. I haven't got any of those in stock, so I'll leave those for now. So everything's working apart from this one. This socket failed when I tried to change it. You can see it's no good, so I need to change that one. While the playfield's lifted up to do the LEDs, I'm just testing the diodes on this drop target bank, which I haven't got it fully working yet. So they're all the same at 0.6 volts forward voltage, and I've tested in reverse and they don't conduct, so they all work. So I'm not sure what's going on. Well, I know that number 4 just doesn't quite have enough tension as it's reading open. You know, it looks like it's closed. We just need to try and adjust that a little bit more. I imagine it might be the same. No, the third one looks okay. Well, we'll find out. I'll test it. These are the switches that had been tortured on the previous Mac, so they don't work great, but I think I managed to adjust that one. Let's just try it, and that's fine. Let's check out number 3 now. Right, number 3 is fixed. Let's just double check 1 and 2 as well. So all the switches apart from these drops were working, but I'm going to go through and clean them all with a contact cleaner anyway while we're here. But let's just test these drop targets out quickly. So first one, 21. Second one, 22. Third, 23. Fourth, 24. Okay, they are all working. Fantastic. So I'll just clean the rest of these contacts and then we should be good. So these are what I use for cleaning the contacts on pinball machines, and this is what they look like. You can see all the dirt from them. So all you do is you insert the strip in between the contact, just apply some pressure and then pull it out like that, and it cleans the contact. Okay, finally I think we have 100% of the lights working. Obviously, pop bump, I need to change that socket. So there is one issue. If we have a look at that one there, that blue one is flashing. So that one there. In fact, so is that one a bit. No, it's just that one. Yeah, so I need to replace the SCR on the lamp driver board for that one. There is an issue with that. As we've already got the anti-flicker boards installed, yeah, that one's got a problem.